Welcome to lesson 2A. We're going to be simplifying radicals going from entire to mixed. So these expressions such as root 2, the cube root of 7, the fifth root of 20 are called radicals. We know that they are also called irrational numbers, but these ones that contain these root signs specifically are called radicals, okay? So just a little bit of definition here. So we know that we have the radical sign. The little number here is called the radicand, okay? And then the number underneath here is called the index. Now it's important to note that if I have like the square root of 12 or something like that, that even though there is no number for the radicand, it's an implied 2 for a square root, okay? Every other one has a radicand there, but with the square root, it's invisible because it's an implied 2, okay? Radicals are said to be in simplest form if the x contains no factor that is the 8th power of a number. So we're going to talk about this explicitly because that just sounds crazy. But we're going to be looking at the number underneath here and seeing if there is a factor of that number. So remember we've looked a lot at factors. So those are things that multiply. So is there something that multiplies into this number that can be square rooted or cube rooted or whatever? And then these two, there's no radical sign in the denominator and the radicand is not a fraction. Okay, so this basically is pre-cal 20 kind of stuff. We're going to deal with point number 1. Okay, so you will probably find it helpful to have a list of the perfect squares and perfect cubes handy. So let's take a peek at those. So I've got them listed here, not all of them, but a few of them. These you should know from past years. You may have seen them written the other way around. So you might have like 2 squared is 4. 3 squared is 9, right? I've written them in the radical form. So the square root of 4 is 2, the square root of 9 is 3. So these are your lists of perfect squares, okay? And then over here, I've got a few of the cube roots. You'll see that those get much bigger faster. So remember that what a square root is this, the square root of 9 is saying what multiplies by itself to give you 9, so 3 times 3. A cube root is saying what multiplies by itself 3 times to give you 27. So 3 times 3 times 3 is 27. All right, so let's go ahead and look at simplifying these radicals. So what you're going to do when you want to simplify is you're going to break the index into factors, okay? So, but not just any factors. You want to try to choose the largest factor that is a perfect square or a perfect cube, depending on what the question is asking you, in order to get done the quickest. So you'll want to make sure that you have a list of those perfect squares or perfect cubes handy if you don't know them, because you'll want to be testing the things to see if they're factors. Then you're going to take the square root or the cube root of the factor and move it to the front of the radical sign, and the non-perfect remain inside. Okay, so let's just do one and you'll see what it means. So basically what you want to do is you want to look at the number 50 and you want to break 50 into factors. There's lots of things you could say. I could say 5 and 10. I could say 2 and 25. I could say 4 and 5. Or sorry, 4 and I don't know what. So I just lost that. Anyway, what you want to do is you want to find the largest factor that is a perfect square that goes into 25. Okay, so I could break it to 5 and 10, but that doesn't help me because neither 5 or 10 has a perfect square. But I can break 50 into 25 and 2. Okay, and the reason I choose that is because 25 does have a square root, right? So I can take the square root of 25, it is 5, and then this 2 is still stuck underneath that root sign. So this is called a mixed radical. Okay, it has a number out in front, and we're multiplying that by root 2. So you could check this by taking your calculator and putting in the square root of 50, and this gives me 7.07. And then if I take my calculator and I check 5 times the root of 2, I get the same thing. Okay, so you can still check them that way, but this is called an entire radical, and this is called a mixed radical. Okay, so the square root of 8, we go, what can go into 8 that is a perfect square? Well, that's 4 times 2. And the square root of 4 is 2. And I leave that 2 stuck underneath there. the square root of 80. So I start going through. I know for sure 2 goes in, but that doesn't help me. So take your list of perfect squares. You're checking 4, 9, 16, 25, 36, 49, all of these numbers. We want the largest one that goes in to 80. So I know that 4 goes in. I'm actually going to do 4 because I want you to see what will happen if you did 4. So if I did 4 times 20, this can come out as 2 root 20. But then 20 still has a factor of 4 that can come out, and that would come out as 2. So then I would have 2 times 2 root 5, which is 4 root 5. Okay? Or if I was on my toes a little bit better, I could have broken this to 16 times 5, and the square root of 16 is 4 root 5. Okay, you can see either way, we get 4 root 5, but you get there much more quickly if you can choose the larger factors. Let's look at some cube roots. So again, we want to have our list of perfect cubes. So the cube root of 56, right? So we're looking at our list of perfect cubes and seeing what goes into 56 that has a perfect cube root. So 8 times 7, and then the cube root of 8 is 2, and this cube root of 7 is stuck inside of there. Okay, 135 breaks to 27 times 5. The cube root of 27 is 3, and that 5 is stuck. That's a mixed radical. 648. So again, I'm going down my list of perfect cubes. I'm trying 8, 27, 64, 125, 216. And if it was more, you could go more. I just gave you the first few of them there, but this breaks to 216 and 3. So the cube root of 216 is 6, and then that 3 is stuck inside of there. So make sure, the one thing I want to point out is that when it's a cube root, you make sure that you keep that index on there, okay? Make sure you don't lose it because a square root and a cube root are two very different things, okay? So that's all there is to converting from a mixed, or sorry, an entire to a mixed radical. So you can go ahead and practice now.